share and subscribe and like.
In this video, we will discuss an important property of an particular integral. When the particular integral is of the type e raised to ax plus by into phi of x comma y, then we can take this term e raised to ax plus by to the left of the operator 1 divided by f of d comma d dash. In doing that, the operator, while taking this term e raised to ax plus by to the left of the operator, the terms d and d dash uh, are changes, and d is increases by a and d dash is increases by b. So this is about an rule of a particular integral. Whenever we move the term e raised to ax plus by to the right of the operator. So let us see an example how actually it happens, and how we can calculate the solve the problem. Okay, suppose we want to solve d minus 3 d dash minus 2 whole square z equal to 2 into e raised to 2x into sine of y plus 3x. Okay, now this is a twice. If we compare this with the integration with the term d minus m d dash minus a, then we have a equal to m is equal to 3 and a is equal to 2. Then complementary function is e raised to 2x f1 of y plus 3x plus x into e raised to 2x f2 of y plus 3x. This is an complementary function. Okay, now this is my complementary function. Particular integral is equal to 1 divided by d minus 3 d dash minus 2 whole square 2 into e raised to 2x sine of y plus 3x. Okay friends, so you are familiar, or you have become a master of finding the complementary function. Our main focus is here to find a particular integral when the term is of the type e raised to x plus by, and how to move this term to the left of the operator. Now here you can see that e raised to 2x plus 0y. If we compare this with e raised to ax plus by, what is the value of a? A is equal to 2 and b is equal to 0. Then we have to when we move this term to the left of this operator, the operator becomes d plus 2 and d dash plus 0. Okay, so as d dash plus 0, that means no change, we do not write anything, but remember that it will be increases by 0, and that means nothing. Okay, so this is equal to, let us see, equal to 2 is constant, 2 into e raised to 2x 1 divided by d plus 2 minus 3d dash, no change in d dash, minus 2 whole square into sine of y plus 3x. Okay, plus 2 and minus 2 will get cancelled, and we have with 2 into e raised to 2x into 1 divided by d minus 3d dash whole square, and it is operating on sine of y plus 3x. Let us make square of that terms, squaring the bracket term d and d dash, and then operating on sine term equal to equal to 2 into e raised to 2x 1 divided by d square minus 6d into d dash plus 9d dash square sine of y plus 3x. Okay, so d square means minus a square minus 1 square minus 3 square minus 3 square minus 9. D dash square means minus b square. What is a b? B is a 1. Minus 1 square is minus 1. D into d dash minus ab minus ab 3 into 1. So we have minus 3. Let us put this value 2 into e raised to 2x divided by d square. Look at this. What is d square? Minus 9 minus 6 into d dash minus 3 minus 9 in plus 9 into d dash square, that is minus 1. Okay, so see here, minus 9 and minus 9 minus 18 and plus 18, and that will be 0. So this is an case of failure. Plus 2x. So don't worry about this. This is a case of failure. Then this is a case of failure. Case of failure. And you know how to handle this case. It is very easy. Differentiate this with respect to d and multiply by x. So 2 into e raised to 2x, we have multiplied by x, and let us take derivative with respect to d. What we get here? Derivative of d, that is 2d minus 6d dash. D dash is a constant, so its derivative, separate derivative is 0, but in the it is in multiplication, so we have 6d dash sine of y plus 3x. Again we multiply and divide by d. Let us take 2 common and cancel. If we take 2 common and cancel, we get here, so let me make some space. You can see that we have and 0 in the denominator, so we have taken a derivative, and then we have multiplied by x. Okay, so 2 get cancel, and we get particular integral is equal to particular integral e raised to 2x into x d divided by d square minus 3d into d dash sine of y plus 3x. Okay, equal to x into e raised to 2x d divided by d square. What is d square? Minus 9 minus 3 into minus 3 minus 3 into minus 3 sine of y plus 3x. Okay, sine of y plus 3x. Then you can see that plus or 9 plus or minus 9, and that will be 0. Again case of failure. Again we get a case of a failure. So we have here again we have the failure case, and therefore the original integral is 1 divided by d into minus 3d dash into sine of y plus 3x. So we differentiate this with respect to d, and when we differentiate we have to multiply it by x, and we get here x square e raised to 2x into sine of y plus 3x. This is my particular integral in this case. Okay, and the complete solution is equal to complementary function plus particular integral. So z is equal to, this is an complementary function, and this one is an particular integral. So what we have done here, again we have differentiated due to again failure with respect to d. We have differentiated with respect to d and multiplied by x, so we get x square, and derivative of d is a 1, derivative of d dash is 0, so 1, and into sine of y plus 3x.
Hello guys, thank you for watching video.